So I thought I'd make a short video here. Some of you have lab on Monday, and for that lab, you're going to have to do some calculations that involve theoretical and percent yield. I did not get to that today in class. Also, your reactions, as I understand it, you actually have a solution that's involved in one of those. So in terms of stoichiometry, there's also going to be a solution involved. So I've got a problem down here. We'll work as an example, and that will hopefully help you to complete those calculations for your lab report. So first off, let's talk about theoretical and percent yield. So we've got two different types of yield here, and when we talk about, let's talk about what percent yield is. So if we think about percent yield, okay, that's going to be equal to equal to your actual yield divided by your theoretical yield times 100 to make it into a percent. So your actual yield would be in lab, let's say. This is how much stuff you got out of your reaction. Your theoretical yield is the total, the possible, if you'd gotten everything, all of your stuff that you should have, and didn't have any losses, and everything completely reacted, that's what your theoretical yield is. And we can calculate that. And we calculate that from the limiting reagent. So this is determined by the limiting reagent. Okay, and so once we got that, we can do that sort of thing. So this is a limiting reagent problem followed by the use of this equation. Let's go ahead. I've got a problem down here that we can work to practice that. And so what I have is I have two things that are reacting. And actually, I forgot to write the equation, so let's go ahead and write that out. I've got sodium hydroxide, and that is aqueous. And that's going to react with, here it says solid magnesium sulfate. So magnesium sulfate would actually be soluble, but we're just saying we're dumping that into solution essentially. I have my sodium hydroxide solution, and I drop my magnesium sulfate into it. And then this is a double displacement reaction, so I'm going to have my magnesium is going to pair up with the hydroxides, and that is a solid. That I know is not soluble for my solubility table. And then my sodium is going to be, sodium and sulfate are soluble. So we're going to have sodium sulfate, okay, and that is soluble. I need to balance this equation. So I'm going to go ahead and put some ones in front of these magnesiums. I've got one magnesium, one magnesium. When I fix one magnesium, then I'm fixing one sulfate, which means over here I'm going to need to put a 1 here, and then I now have two sodiums on one side, and so I'm going to need two sodiums over here. So I'm going to go ahead and erase those ones because we don't carry ones. I do want to make sure I'm okay, though. I've got two hydroxides and two hydroxides. It looks like it's all good. So the equation's balanced. And so the first thing I want to do is I want to figure out if all my sodium hydroxide reacts, how much magnesium hydroxide would I make? I have taken the liberty of, so we're trying to figure out how much magnesium hydroxide in grams, because we're going to need that. Here it is in grams, and we're going to need that in grams to talk about our theoretical yield and to calculate our percent yield. And I took the liberty of actually looked these up, I didn't calculate them, but looking up these molecular masses so we wouldn't need to calculate them as we went. Trying to keep your video short. All right, so we're going to go ahead and do this first equation. So I start with 150 milliliters of a 0.55 molar solution. This 0.55 molar solution is a conversion factor. So what that says is 0.055 moles, because remember, molarity is equal to moles per liter. So 0.55 moles of sodium hydroxide is going to be equal to 1 liter of sodium hydroxide. We're going to use that as we go through this. So I'm going to need to put my 150 milliliters in liters. So I have 150 milliliters of sodium hydroxide. All right, if I had 1,000 milliliters of sodium hydroxide, that would be equal to 1 liter of sodium hydroxide. Milliliters cancels with milliliters, and so now I've got liters of sodium hydroxide, and I am ready to use this conversion factor right here. And so 1 liter of sodium hydroxide is going to be equal to 0.55 moles of sodium hydroxide. Okay. Liters cancels with liters, and I've got moles of sodium hydroxide. Now I need to figure out, if I have that many moles of sodium hydroxide, how many moles of magnesium hydroxide will I get? And I'm going to use these coefficients here to figure out, go from moles to moles. So if I have 2 moles of sodium hydroxide, excuse me, that's going to give me 1 mole magnesium hydroxide. Okay, moles of sodium hydroxide cancels with moles of sodium hydroxide. And then finally, if I want to get grams of magnesium hydroxide, I can use my molecular mass. So 1 mole of magnesium hydroxide is going to be equal to 58.32 grams of magnesium hydroxide. Okay, those cancel, and so now I'm ready to put this into my calculator. I'm going to multiply everything across the top and divide by everything on the bottom. So 150, I'm going to just skip my ones, times 0.55 times 558.32 divided by 1,000 divided by 2 equals, I get 2.4 grams of magnesium hydroxide. And when I look back over my significant figures, I have 2 significant figures as the smallest number I see out there. So 2.4 grams of magnesium hydroxide. All right, so that's how much magnesium hydroxide I would get if all of the sodium hydroxide reacted. So in other words, if the sodium hydroxide reacted with excess magnesium sulfate. I'm going to go ahead here and try to erase a bunch of my marking. Okay, so now we need to figure out if all of my magnesium sulfate reacts, so it's with excess sodium hydroxide, how much would I get? Let's go ahead and figure that out. So here I have, the problem tells me that I have 73.21 grams of magnesium sulfate. So I have if I have 73.21 grams of magnesium sulfate, then I need to go to moles of magnesium sulfate, so then I can then go to moles of magnesium hydroxide. If I have 120, I'm using the molecular mass here, 120.37 grams of magnesium sulfate, I would have 1 mole of magnesium sulfate. Grams of magnesium sulfate cancels with grams of magnesium sulfate. And then I'm going to look at the ratio in this problem. It looks like here I've got a 1-to-1 ratio here. So I'm actually going to write it out. If I have 1 mole of magnesium sulfate, and you, by the way, should also write it out, even though it's a 1-to-1 ratio, so that if your professor in either lab or in class is checking your answer and your answer is incorrect and they're going to look for partial credit, that they can see you understood that you needed the mole-to-mole ratio here. That said, I've got a mole of magnesium sulfate. It cancels with a mole of magnesium sulfate. And now I'm in moles of magnesium hydroxide, and I'm ready to use the molecular mass of magnesium hydroxide. So 1 mole of magnesium hydroxide is equal to 58.32 grams, just like above, of magnesium hydroxide. And I am ready. Moles of magnesium hydroxide cancels with moles of magnesium hydroxide. I'm ready to multiply across the top. So 73 and divide by the bottom. 73.21 times 58.32 divided by 120.37. And that's everything I've got that isn't ones. And so I get 35 grams. 35.47 grams of magnesium hydroxide. Okay, so that's how much I would get if all of the magnesium sulfate reacted. All right, I see I made up this problem, and I see I have a problem up here. And I'm going to fix it in a second. I'm not going to remake the video, but I'm going to have to adjust that because you're getting more than possible. But so what we've got here then is my limiting reagent here is the sodium hydroxide because it makes less. So the total possible amount of magnesium hydroxide I could make is 2.4 grams, which shows me I have a problem with this up here. So what I'm going to do is I'm going to scribble this out, and I'm going to say that I had 1.05 grams of magnesium hydroxide that formed. Okay, so 1.05 grams is how much you got, not the other number, which was impossible because it would have been you got more than was theoretically possible. And so now I've got 1.05 grams and I've got 2.4 grams. So what that tells me is the 2.4 grams of magnesium hydroxide is my theoretical yield. All right. If I got everything possible, if everything reacted, I didn't lose anything purifying it, that would be the maximum possible yield I could get, because I've only got enough sodium hydroxide to make that much. And then my actual yield, we just changed it to make the problem work. My actual yield was 1.05 grams, so that's how much I would have weighed out in the lab maybe after I had done my reaction. My actual yield was 1.05 grams of magnesium hydroxide is actual yield. And if you remember from up above, our percent yield equation is going to be equal to actual, I said just yield up above, but let's just call it actual yield, over theoretical yield times 100. So let's go ahead and put those numbers in here. My actual yield is 1.05 grams over, and that's of magnesium sulfate, no, of hydroxide, sorry, of magnesium hydroxide over 2.4 grams of magnesium hydroxide times 100. And so I'm going to go ahead and put that in my calculator. I'm going to take 1.05 times 100 divided by 2.4, And what I get is 40, I've got two significant figures over here, so I'm going to say 44% is going to be my percent yield there. Okay, so that's how we can do those sorts of solution calculations to get a theoretical yield, and that's how we calculate our percent yield in one of these problems. I hope this has been helpful. If you have any questions, please reach out, and I hope you folks are having a good weekend.